Alright guys, so sorry that I'm absent, but I'm going to go through and explain note 7.1. So all of my answers are up on Schoology, but if you had any questions about my answers, so I tell you that I make 25 pancakes and I'm asking you how many teaspoons of baking powder I will need. So I start with my given, which is the 25 pancakes. I'm going to do I'm doing a conversion, so I'm going to put pancakes on the bottom in order to get rid of that unit. Those will cancel. And I put teaspoon. While this is a recipe, we're going to treat it like any chemical reaction that occurs. So the 1 cup, the 2, the half, the 5, all of these, 1, 2, 1/2, 5, those represent the coefficients like what we would have in a normal chemical equation. And so here that's in front of pancakes, and the 1/2 comes from the 1/2 here. So 1/2 teaspoon, 5 pancakes. So what I'm going to do to get my answer, I'm going to take 25, multiply it by 0.5, and then I'm going to divide by 5. And so my answer is going to be 2.5 teaspoons. Okay. For the next one, your given is 4 cups. So I have 4 cups of flour, and it asks how many pancakes I can make. So if we look at our reaction up above here, I know that I'm going to have 5 pancakes for every 1 cup of flour. So I'm going to put cups on bottom so that they'll cancel, pancakes on top, and then I can simply put 5 and 1. And so my answer that I get is 20. Okay. For the last one, if I made 6 pancakes, how many eggs did I use? So I start with 6 pancakes, that's my given. Then I'm going to convert, I'm going to get out of pancakes by putting pancakes on bottom. And I want to get into eggs, I'm going to put eggs up top. Now the coefficient in front of eggs in your recipe up above was 2. And then 5 pancakes was in front of the 5 was in front of pancakes. So I'm going to take 6, multiply by 2, then divide by 5. And so the answer I got was 2.4. Now a lot of people freaked out and were like, you can't have 2.4 eggs. Well, technically you could. You can mix 3 eggs together, get rid of approximately 0.6 eggs and have 2.4 eggs. So don't worry about that. That's not the purpose of this. The purpose of this is for you guys to understand between, for example, flour to eggs, or eggs to baking powder, or baking powder to pancakes. Being able to say, okay, if I have a certain amount of one of these, how many pancakes can I make? Or if I want to make this many pancakes, what amount of baking powder, eggs, or flour do I need? All right, so let's actually look at this from a chemistry point of view. So I'm on the next page. It gives you the formula. Aluminum reacts with oxygen to produce aluminum oxide. Now the first thing you've got to do for any of these, now that I'm converting between units of one of these entities, one of these reactants into products or products into reactants, is you have coefficients, okay? So to balance this, because I've got 3 oxygens here and only 2 here, I'm going to put a 3 in front here to make that 6, a 2 in front here, so then that would make that 4 aluminum. So this is my balanced reaction. It now says how many moles of aluminum are needed to form 3.7 moles of aluminum oxide. So I have 3.7 moles of aluminum oxide. I'm going to crisscross swoosh. I'm going to put moles of aluminum oxide on the bottom because I want to get rid of them, so those will cancel. And I'm going to put moles of aluminum up top. So then I'm going to take the coefficient, so I have a 4 for aluminum, a 2 for aluminum oxide, and so I'm going to take 3.7, multiply by 4, divide by 2, and the answer I get is 7.4 moles. It's 7.4 because I have 2 significant figures here and 2 there. The next problem says how many moles of oxygen are required to react completely with 14.8 moles of aluminum. All right, so I start off with my given, which is 14.8 moles of aluminum. Notice how much detail I'm putting with respect to my units. I'm not just saying moles, I'm saying moles of aluminum, okay? So I'm going to put moles of aluminum on bottom so that those will cancel. And I'm going to put moles of oxygen up top, okay? The coefficient in front of oxygen is a 3. The coefficient in front of aluminum is a 4. And so I'm just going to multiply the 14.8 by 3, divide that by 4, and the answer I get is 11.1 moles of oxygen. For the next reaction, I first have to balance. So if you notice, I've got 4 oxygens here, 5 oxygens here, and so what I decided to do was to put a 2 in front here. That would make that 10, okay? And then as a result, I have 4 nitrogens now, so I'm going to put a 4 here, and then that would give me 4 times 2 is 8, plus 2 is 10 oxygens. So that was a little bit of a challenging balance. Then what I'm going to do is I write my given, which is 1.3 moles of N2O5. Please make sure you're showing all of these units. Okay, crisscross swish. I'm going to put moles of N2O5 on bottom and moles of NO2 up top. Okay, the coefficient in front of NO2 is a 4. and 2 for N2O5, because there are 4 moles of NO2 for every 2 moles of N2O5. Multiply, then divide by 2, and I get 2.6 moles of NO2, and I'm keeping consistent with my 2 sig figs, 2 sig figs. All right, so now what this wheel lets us do, we had done, for example, in the previous unit, we went from grams to moles or moles to grams, or from particles, right, atoms, molecules, or formula units, into moles or moles into particles, or we could have gone from grams all the way over to particles. Now what this allows us to do is to go from moles of one entity, moles of A, into moles of another entity, into moles of B. And so this is what we just did in the last section, using your mole to mole ratio. And so at this point, nothing is new. All you need to know is that, for example, if I ask you, like I do in number 1, to go from grams of one thing into grams of another, you've got to go from grams into moles. Then using your mole to mole ratio, you're going to get into moles of the other entity, and then you can get into grams. Okay? In order to go from units of one element or one compound into another, you've got to get into moles so that you can use your mole to mole ratio. So let's look at this one. It tells me I have 5.0 grams of calcium carbide. Okay, so I write my given, all of the information there. Okay, please don't skimp out on information because you'll mess yourself up. I made sure to balance up here. I have 2 in front of H2O. Now I'm going to go first from grams of calcium carbide. I'm going to get into moles of calcium carbide. So I put grams on bottom, moles of calcium carbide up top. Okay, I'm not going to explain my numbers yet. I'm going to just keep going. So I'm now in moles of calcium carbide. I want to get out of that because it's asking for grams of acetylene. So I'm going to put moles of calcium carbide on bottom so that those will cancel. Moles of acetylene on top. Now I'm in the compound that I want to be in. I'm in C2H2 in acetylene, but I'm not in grams, and that's what the question's asking for. So I'm going to do one more step. I'm going to get out of moles of C2H2 and into grams of C2H2. Okay? Now come the values. So as soon as you see grams per mole, right, grams and moles, you know that you're going to have to use molar mass. Now notice how useful all of my units are. I purposely wrote moles of CaC2 to help me later on, but then also to remind me when I go back to plug in my numbers, I need to be putting the molar mass of CaC2. So you take the molar mass of calcium, add to that the molar mass of carbon times 2, and I got 64.02. Okay? Then for your mole to mole ratio, remember you're just going to be looking at the coefficients. Well, the coefficient in front of C2H2 is a 1. The coefficient in front of CaC2 is a 1 as well. Does that mean you don't have to show it? No, you absolutely do. Okay, so make sure to show the 1 to 1. Then for here, notice again, I put moles of C2H2 on bottom just to remind myself, hey, you need to find the molar mass of acetylene. So I'm going to take the molar mass of carbon, multiply by 2, and add to that the molar mass of hydrogen times 2, and I got 26.04. Okay? Then I'm going to take 5, divide by the 64.02, then multiply by 26.04, and the answer I got was 2.03 grams. Now, some of the questions I can anticipate from you guys. Number 1, if you got a slightly different molar mass than I did, right? If you rounded less than I did, right, you have an extra digit here, you might have gotten a slightly different answer here. That's perfectly fine, okay? If it's 2.04, 2.05, that's okay. I just rounded because I was kind of in a rush. Now, if you have a completely different molar mass than I did, check with your partners and see if I made a mistake. I did this in a rush because I realized I wouldn't be here today. So just check it. If I made a mistake, I apologize. Shoot me an email and let me know. But this is the answer that I got. All right, let's look at the second problem. So it says, how many grams of oxygen form when 0.361 grams of potassium chlorate react in this reaction? So I first need to balance, okay? So I saw that I had 3 oxygen atoms and 2 oxygen atoms, and so what I did was I put a 2 in front here to make that equal to 6 of him and 2 chloride ions, and so I put a 2 in front of potassium chloride right there. Now I start with my given 0.361 grams of potassium chlorate. I know I'm going to want to get into grams of oxygen. And so the first thing that I'm going to do is I'm going to go from grams of potassium chlorate into moles of potassium chlorate. Okay, notice all of the units that I'm sharing. Okay? Then for moles of potassium chlorate, I want to get into moles of oxygen. So I'm going to put moles of potassium chlorate on bottom, moles of oxygen on top. Then I'm going to do one more step because I want to get into grams of oxygen. So I'm going to get out of moles of oxygen by putting it on bottom, and then put grams of oxygen up top. Now I got to plug in my number. So grams per mole, I know I'm going to have to use the molar mass. I know I'm going to have to use the molar mass of potassium because I included all of this information. So I got 122.55. Then for here, the mole to mole, I need to be using the coefficients for oxygen and potassium chlorate. So I got a 3 here because that's the coefficient for oxygen, a 2 for potassium chlorate, and then for here, grams per mole of oxygen. So I know that I need to put the molar mass of O2, which is 32. Okay, so if you got slightly different rounded values, that's perfectly fine. If you got a completely different answer, check your work and then let me know if I did it incorrectly. So I'm going to take 0.361, divide by the 122.55, multiply by 3, divide by 2, and then multiply by 32. And the answer that I get is 0.141 grams, right? One last thing that I wanted to mention, I'm going to go back really quickly. I saw for some people what they were doing for these problems was, for example, if I asked for moles of aluminum here, which I did, a lot of people went from moles of aluminum oxide first into moles of oxygen and then into moles of aluminum. Keep in mind, you can convert between moles of aluminum directly into moles of aluminum oxide, vice versa. You can go from moles of aluminum oxide directly into O2, into moles of O2, or you could go from moles of aluminum into O2 or O2 into aluminum. You just have to be using these coefficients. So it's not like you have to go from moles of this into moles of that into moles of that. No, it should only be one step no matter which elements or compounds you are using. Okay, that's it. So you should be working on worksheet 7.1 now.